Hey there, Python programmers. Welcome back to our Wordle code along. So in this video, we're going to be tackling the update display method, by far the most complicated and longest one. Pretty much at this point, we have all of our logic. We are collecting guesses. We are updating all of the class attributes that we need to. So really, this is all about displaying the information we have. Now let's quickly go to the actual game we have working and kind of talk about that process. So we're going to type in a guess. It's going to print it. We type in a couple more guesses. So there we go. And okay, cool. Wow. So it looks like a tough word. So what task is ahead of us? Again, we have to redraw the entire game board each time because really what we're doing is clearing what we have and then drawing it back again. It just happens so fast we don't notice. This is a very iterative process. For starters, we have to print out all the words. So every guess we have, if we've made a guess, we got to fill it with the letters of that guess. If we haven't made a guess, we still have to print out the blanks. We also then have to go through each word looking at each letter in the word, because again, we need to check for two things. Is this letter actually in the winning word? And is it in the right space? If it's in the right space, like we have our R here, we had to check that R is the second letter and in the game word. Now, again, if it's not in the right spot, but it is in that word, we have to make it a different color. So we're going to have to go through each letter and each word, and we're going to print one letter at a time because we can, and because again, we have to make some changes before we print. Sometimes we're not printing any new background. Sometimes it's going to be yellow. Sometimes it's going to be green. Once we've printed green, we are going to keep printing things green unless we switch it back. So that's where our Colorama package is going to come in as well. And again, this is our task ahead of us. So let's jump in and get started. Now, the first thing we're going to want to do is have another os.system. And again, we are just clearing our screen. CLS is going to work on a Mac. On Windows. You might need to do clear instead. Basically clears the thing blank. So now we can start our printing. So we have to print each word that is stored in our self.guesses. To me, that sounds like a wonderful for loop. For word in self dot guesses. And this is how we're going to iterate through word by word. Now, as we iterate through this, we have to check one thing. Basically, what we need to check is, do we have anything saved there, right? Because if we have a guess saved, we're going to have to do something very different than if we don't have a guess there yet. So the first thing we'll want to do is check the length of the value. Again, these last two, they're technically arrays or lists inside of lists. They don't have anything in them. So we're going to want to check our length. And if is greater than 0, right? So if the length of the word is greater than 0, it means we actually have a legit word. And what I actually want to do is come back to this, because what I want to do first is the else. Again, if there's nothing there, because this might show us a little bit about how we're going to deal with if there is a word there that we need to print. So we'll do the else side real quick and then come back. So if we don't have a word, we just need to print our dashes 5 times, but also spaces. So let's do that. I am going to make a variable called display, and I'm going to use a list comprehension, and I want to put an underscore, makes sense, right? For every value. And again, if I just need a placeholder, I'm not going to use that. I just need this list comprehension to do something a certain amount of times. And that's going to be in a range again. And then to range, we want to provide the length of self dot. It could be game word or it could be letters. Either one is going to work. We just need to tell it to do it as many times as letters we have. And again, we want it to be dynamic because if we have 6 letters, we need to print 6 blanks. If we have 4 letters, we need 4 blanks. So what this is going to do is make a list of however many underscores we have letters. And then what we can do real simple to print it, do print, and we are going to go ahead and join on an empty space. Remember, join takes a list and it puts them together. And if you want a space between them, well, that's whatever string you put here. So if we wanted a dash between them, we put a dash there. We're going to join them. And then what we're joining is the variable display. So this else statement is going to go ahead and make these blanks for us. However many letters we need, it's going to print an underscore and a space. And that's basically what we got. So we created this variable that we built up to then print. And that's why I wanted to talk about this one first, because that's what we're going to need to do up here. It's just there's going to be a lot more work involved, unfortunately. So let's get to it. I'm going to make the same display variable, and it's going to be a list, but I'm going to have to do a little more work. I'm actually going to have to iterate. I am going to need both an index and a value. So for this, we are going to use one of our favorite built-in functions, enumerate. And we're going to pass in the word to enumerate, because again, we are going to need to look at each letter in here, but we also need the index for our green checking, right? Because if we're going to look that R is in the third place, well, we're going to need an index to get into the game word to make sure the third place value there is the R. Cool. So now as we iterate through, I am going to build up my display. It's going to be a little more complicated with the letters though, because now I have to worry about colorizing things. So we're going to have a couple of choices. If the letter equals our self.gameWord indexing into that same letter. That's why we need the index. It means, hey, we have the right letter in the right spot. We got to make these green. So what we'll do is display.extend. Remember, extend is like append. It's going to add something to the end of our list, but it allows us to add multiple values or like a whole list to concatenate that. So let's do that. We are going to add a list. And again, if we're in this scenario, we need to make it green. This is where we start using our two imports from Colorama. We have back and style. Back is going to go ahead and change the background color to whatever we choose. So if we do back dot green, it's going to make the next thing it prints green. Cool. Now we want to print the letter and we want it to be uppercase. But remember, we are storing them in lowercase. So basically we set the background to green, then we print our letter. Then the next thing we're going to do is reset it back to the default. And that is where the style import, and that has an attribute called reset. Makes a lot of sense, right? It's actually reset all. That's going to reset back to whatever our default is. So what we're doing is we're saying, hey, we're right here in the printing process. We turn things green, the background green, then we print our R. Now we need to turn it back to our default. And then we print a space, because again, there is a space between each one of these, and that just makes it more readable. So don't forget, we also need to add a string of a space. So this is basically putting each one of these commands as an item in our list. Cool. What we need to do is basically keep doing this for each letter in a word. And then once we've built up our display with basically the commands to print, we're going to go ahead and feed that to a print command. So hopefully that makes sense. Really now we just need to get the other scenarios in here, right? So that's what happens if it's the right letter in the right spot. Let's throw in an elif here. And again, if our letter is in self.gameWord, right? If it's in the game word, and we don't really need to do this, but it doesn't hurt, we also really want to make sure that the letter does not equal basically our game word at this index. Self dot game word at the index. Now, would that really ever happen? No, because it would have been caught here, right? If it equals them, hey, it's going to be part of this, but this does let us practice using and syntax, and it doesn't hurt. Cool. So if this is scenario, basically it's the same thing as above. Just for time's sake, I am going to copy it. The only thing we need to do is change printing it green to yellow instead. Boom, boom, boom. Everything else needs to just work the same. Again, we want to make it yellow, then print the letter, then reset it back to our default, and then print that wonderful space. And the last, we have our else scenario. And we still need this because, again, if nothing matches, we still need to print that letter. So I'm going to copy this over. Now, we don't need to change it. We probably don't need to put the command I'm about to put in either. But again, it doesn't hurt. We want to make sure everything is reset to all, and then we want to print the letter. Again, can't hurt to make sure it's still reset to all, and then print a blank. So now we have our three scenarios. And again, this is examining a letter, and we're building up this display, which now has just tons of instructions. So all we need to do now is go through it and print them. So let's give that a shot. Sounds like it's going to be another iterative process for us. And in this scenario, I'm also going to want to index too. So we're going to do the same for index. And this will be word, because we're going to be looking at a word. In good old enumerate, and we're going to enumerate over our display. All right. And now we have two scenarios here. And that is if we're at the end of a line or not, because we're going to have to do a different command one way or the other. So again, if our index equals the length of our display, but we have to back away one value. And I will tell you the reason for that is our display technically has a extra space on the end here. See, if I highlight it, we can kind of see it is printing a space. So really, we already have the instructions to print this end space. So we want to do that when we are the second value to the end. And that's why we just need that -1 to back one away. And if that's the case, we want to print the entire word. And I'm going to explain this in just a second. Control. Cool. So we want to print our word. And then we need our else scenario. And this again is if we're not at the end. Every other print, we need to have a very special print command. We still want to print our word, but what we want to do is add n equals nothing. So hopefully we know that each time we do a print like this, after it prints the value, it goes to a new line. That is the default end for print. Technically, it is that. So whenever it prints whatever we need it to print, this is what will happen at the end. It'll go to a new line. That is great if we're done, right? That's why we have to check if we're at the Y or the blank. We're at the end, we want it to print and then go to a new line. But up to that point, again, we might have to change the colors. So we only want it to do one print at a time. And by changing the end to basically nothing, it will just keep printing in the exact same line for us. Pretty cool. Now let's see, it looks like we have an error somewhere, so we better find that out. Let's check our problems. Let's actually just look like spelling errors. So let's give our game a run. Bomb. All right, what do we have here? Oh, it looks left. Sorry, there is our error. Missing a colon. Control. All right, we are running. Let's see how our Wordle is. Let's guess letter. Fling. Looks like we're colorizing it. Champ. Going good so far. Um, Tubes. How about wordy? Oh, we have no green so far, but can we guess this? We have all of our letters. LHUAG. Ooh, none of them in that order. Well, let's go ahead and just make a couple more guesses. I want to test L-A-U-N-G, whatever. Oop, L-A-U-N-G. Oh, cool. So let's see. The word was laugh, out of tries, but hey, we got to test now. We can see we are colorizing our green correctly. Let's go through one or two more test runs, right? Let's do fling again. What if we try fling again? Right? We shouldn't be allowed to do the same word twice. Awesome. Let's try a word that's too big. Cool. Word that's too small. Awesome. Let's do chain cleared. Ooh, we're doing much better this time. Let's do tubes. What do we got? LA. We have all of our words. So something LAPL. Place. Let's try place. We got it. We won. Looks like everything is working. So super awesome. Again, I know this last update display was a big one, but this is pretty commonplace in making game logic. You have to kind of handle all the logic, the guessing, storing the information. But at some point, you have to have something that's going to, update the screen with all the information. So again, definitely makes sense. We covered a lot of things we've learned about here. So this is typically a great review. Hope you enjoyed watching these game videos. At this point, I will push the solution up to the repo as well, so you have it there. And hope you enjoyed this. Don't worry, I'll make some more games. Don't forget to like and subscribe, and I will see you soon, Python programmers.